The last part in this then is combustion analysis, and you can already do the empirical formula, molecular formula calculations, but combustion analysis is basically where we get this information from here. It's where we get these masses of carbon and masses of hydrogen and potentially masses of oxygen from as well, in order to be able to do this. So we do this by something called combustion analysis, okay? So just a little recap on how we work out empirical and molecular formulas. So we get our masses from combustion analysis. If you remember, we then have to convert our masses to moles by dividing by the AR. We then have a molar ratio between the two here, which if we divide by the smallest, so that's the next step, so divide by the smallest, we should get a more manageable ratio to look at here. And remember, if we've got halves, we need to times it by 2. If we've got thirds, which will be around about 0.33 recurring or 0.66 or 0.67 recurring, we then need to times them by 3. That gives us our empirical formula. We then use the mass spec for the molecular ion peak, the MZ, which is the MR, which then allows us to convert that to the molecular formula. So that's just a recap, okay? So in terms of kind of how we work out how much carbon and hydrogen that we get in all of these things, I've just drawn a little model here. And this is just a simple combustion reaction of methane, which forms carbon dioxide and water. Now, here's the key thing in this, all right? So I hope you can see that the carbon that was in the methane is the carbon that is in the carbon dioxide that has been produced. Now, here's the key thing about that. The mass of the carbon dioxide molecule is 44. That's 12 plus 16 plus 16. But the mass of the carbon that is in the carbon dioxide is 12. Now, what that means is that 12 44ths of whatever mass of carbon dioxide you have is the mass of carbon that you started with in the first place. Okay? The second thing that we need is the hydrogen. And again, if we just look at where the hydrogens have gone, so all the hydrogens from here have ended up over there. Okay? So all the hydrogens that were in the hydrocarbon at the start have ended up with the hydrogens in the water. And we apply exactly the same principle. So the mass of a water molecule is 18. That's 16 for oxygen plus 1 for each of the hydrogens. Okay. Now the mass of the hydrogen in water is 1 each, isn't it? So those two added together, those two single masses, mean that 2/18ths of whatever mass of water you have after combustion is the mass of hydrogen that came from the hydrocarbon in the first place. Okay, so that's the key thing in terms of how we get the mass of carbon and the mass of hydrogen. So if we go back to this, so that's basically this bit here, okay? So we've got our, we get our mass of hydrogen by doing 2/18ths. We get our mass of carbon by doing 12/44ths. Any mass that is left over is going to be oxygen, because if you think about it, it's reacting with oxygen. Most of our hydrocarbons tend to have oxygen anyway. Sometimes they tell you that it's going to be oxygen, but sometimes they don't. You have to do a little check, which I'll go through in the examples. So here's the first example then. So you're told in the question you've got 1.5 grams of a hydrocarbon that undergoes complete combustion to produce 4.4 grams of carbon dioxide and 2.7 grams of water. That is what we start with here. We're basically adding an extra row before we get to the masses that we use in our empirical and molecular formula calculations. So I've got my mass of my carbon dioxide and my mass of water, and we know that 12/44 of the mass of carbon dioxide is carbon. So that's the first thing I do. Times it by 12, divide it by 44, that gives me a mass of 1.2 grams. So my hydrocarbon has 1.2 grams of carbon. With the water, applying exactly the same. So the water, remember, is 2/18. Okay, so 2.7 grams of water was produced. So times it by 2, divide by 18, that gives me 0.3. Now here's the bit that people often miss out. You've got to check to see whether there is any oxygen present. And to do that, we add the mass of carbon and the mass of hydrogen together. If it is equal to the mass that you started with, it doesn't have any oxygen. If it is greater than the mass that you started with, the difference is oxygen. Okay? So from here, it's exactly the same as what we were doing before. We've got our mass of carbon and hydrogen, so we now divide by the AR, which gives us our molar ratio here. We then divide by the smallest, which gives us a more manageable ratio here, which then gives us our empirical formula. And of course, if we were given the molecular ion peak or MZ peak from mass spec, we will be able to convert that to a molecular formula. So here's another example. So 0.25 grams of an unknown sample contained carbon, hydrogen, and oxygen. So in this question, you're told that you are going to have to work out that there is some the mass of the oxygen. Sometimes it doesn't. You always have to do the check. Okay. So undergoing complete combustion produces 0.3664 grams of carbon dioxide and 0.15 grams of water. So again, we start with the masses of carbon dioxide and water. We take our carbon dioxide, times it by 12, divide it by 44, which gives us our mass of carbon here. We take our mass of water, times it by 2, divided by 18, which gives us our mass of hydrogen. And again, what we have to do is we add these two together, which is this step here. Take it away from our starting mass, and I hope you can see that I've got mass left over. This mass that is left over is oxygen. Okay, so I've now got my mass of carbon, hydrogen, and oxygen, which, as before, I go through and divide by the AR, which gives me my molar ratios between all three elements. Divide by the smallest, which gives me a more manageable number. Remember about the halves and thirds. And that gives me my empirical formula here. And again, if I had the molecular ion peak or the MZ value, I'd be able to work out the molecular formula from that. Okay. So again, part of your homework that you're going to have to do is to complete these questions here and email me them for marking. Okay. So hopefully that will help you while you're going through this week's work.